Hello. Right now, I'm going to discuss to you the sensitivity analysis on the effects of physiographic factors on the stream flow of Bulacan. But before that, let me take you to Bulacan River, or what they call the Angat River. Just watch this full video. Wait a minute. So, that's the Angat River or the Bulacan River located in Bulacan, Philippines. I would like to thank the SGTM Bulacan for this picture. Thank you so much.
Grabe, lawak ng ganda. 1.5 hour. Imagine, ito po yung iniinom nyo.
So let's move on to the profile of Bulacan. Profile of Bulacan. Bulacan in Tagalog, lalawigan ng Bulacan. Kapampangan, lalawigan ng Bulacan, is a province in the Philippines located in the Central Luzon region. Region 3, in the island of Luzon, 11 kilometers or 6.8 miles north of Manila, the nation's capital, and part of the Manila-Luzon Urban Beltway Superregion. Bulacan was established on August 15, year 1578. So, Bulacan has a total land area of 262,500 hectares, or roughly 14% of the total area of Central Luzon. The biggest Philippine island and 0.9% of the country's total land area. The province has 21 municipalities, 3 component cities, and 569 barangays. Malolos in the southwestern part is the capital of the province. Of the 21 municipalities and 3 component cities of the province, Dona Remedios Trinidad or DRT is the biggest municipality, having a total land area of about 93,298 hectares, or almost 36% of the provincial land total. DRT is followed by the municipalities of San Miguel, Norsagaray, with land areas representing more than 6% of the provincial total. So much for that. Let's move on to the contour map. So this contour map is being gathered to the Google map. Then next, this contour map is being gathered to the Google Earth. And then next, this contour map is being done by the AutoCAD. So next is the model of Angat River. So the Angat River has 5 sub-basin, sub-basin 1, 2, 3, 4, and 5. Then it has a 4 junction where 2 sub-basin meet to each other, the junction 1, junction 2, junction 3, and junction 4. And the model of Angat River has also 4 reaches. So this the reach 1, reach 2, reach 3, and reach 4. and it has an outlet draining to the Pampanga River Basin. So the Angat River is considered a sub-basin of the Pampanga River Basin. So let's move on to the rainfall data. The following rainfall data are gathered with the help of worldweatheronline.com. So thank you. So to the monthly rainfall data, starting with January, February, March, April, May, June, July, August, September, October, November, December. So as we can see, the August has the highest rainfall amount, which is amounting to 1,000 millimeters. So because the August has the highest amount of rainfall, let me see the daily amount of rainfall in the month of August 2016. So, yan, as we can see, the August 15, 2016 has the highest amount of precipitation or rainfall, amounting about more than 60 millimeters of rainfall on that day. So much for that. Let's move on to the methodology. So first, the development of the basin model. Number 2, determine precipitation or rainfall or areal average. Any method of what you want. Number 3, parameterize the basin model. Number 4, add stream flow and precipitation gauge information. Number 5, create a meteorologic model. Number 6, create and run a simulation. Number 7, calibrate the model and evaluate model performance. And number 8, create an uncertainty analysis and evaluate result. So that's it, the methodology that we have done to this modeling of Hec-Hms. So let's move on to the results of the modeling on the sub-basin, the junction, reach, and outlet. So first, the sub-basin. What is sub-basin? Sub-basin or sub-basin is a structural geologic feature where a larger basin is divided into a series of smaller basins with intervening intrabasinal heights. Some subbasins are referred to as sags, although the term has a broader definition than a subbasin does. So if we remember, the Angat River has five subbasins. So first, the sub-basin 1. So that is the result of the sub-basin. So that is the result. So next, we can see the graph of the sub-basin 1. Results for run 4. So this is the outflow of the sub-basin 1, and as we can see, it being flows at the peak of August 15, 2016, amounting 7 cubic meter per second. At the upper part, we can see the depth of flow, wherein this blue part is the excess and this red part is the loss. So if we're going back, this is the red color, which is the loss, and this is the excess, which is the color blue. So if we're going to sum up this, the loss in sub-basin 1 is amounting about 83.71 millimeters, and the excess flow of precipitation is about 67.9 millimeters. So, let's move on to the Sub-Basin 2. Sub-Basin 2 and Sub-Basin 1 are almost the same. So, let's move on to the Sub-Basin 3. So, to Sub-Basin 3, the losses, these losses is about 94.73 millimeters, and the excess flow of precipitation on Sub-Basin 3 is 402.5 millimeters. So next, the Sub-Basin 4. To the Sub-Basin 4, the losses is about 159.95 millimeters, and the excess flow of precipitation is about 376.29 millimeters. Then last, the Sub-Basin 5, wherein its losses is about 195.78 millimeters, and the excess is about 340.07 millimeters. So as for conclusion for the Sub-Basin, the Sub-Basin 5 has the highest amount of losses, and the Sub-Basin 1 has the highest amount of excess flow of precipitation. So let's move on to the junction. So as we define junction, is a place or point where two or more things are joined as a seam or joint. So if we're going to remember, there are 4 junctions in Angat River. So first, we're going to look near. There is an inflow from Sub-Basin 2, then inflow from Sub-Basin 1, and outflow. So, as we remember, junction 1, wherein the Sub-Basin 1 and Sub-Basin 2 meet each other. So, if we're going to look the graph for this junction 1, so this wool line or the continuous line, this is the outflow. Then this line, second line, under the second line under the outflow is the inflow from Sub-Basin 2. Then this line, this line is the result of inflow from the Sub-Basin 1. So as we can see, the outflow has the highest amount of water or rainfall. So next, junction 2. As we can see, there is an inflow from Reach 1 and inflow from Sub-Basin 3 and the outflow. So if we're going to remember again, Reach 1 and Sub-Basin 3 meet at the junction 2. So therefore I conclude, outflow has the highest amount of water or rainfall. So next, the junction 3. Inflow from Reach 2 and inflow from Sub-Basin 4. Then the outflow. So if we're going to remember again, Reach 2 and Sub-Basin 4 meet at the junction 3. So again, they are almost equal but not at all. So therefore I conclude that the result of inflow to the Sub-Basin 4 as the lowest amount of water. So next, to the junction 4. So as we can see, the inflow, there is just an inflow and there is just an outflow. So yan. So that's it. The whole line is the outflow from reach 4 and the broken lines is the inflow from reach 4. So that's it. They are almost equal. So next, we're going to discuss about reach. So a reach is a section of a stream or river along which similar hydrologic conditions exist, such as discharge, depth, area, and slope. It can also be the length of a stream or river with varying conditions between two stream gauges, or a length of river for which the characteristics are well described by readings at a single stream gauge. So if we're going to remember or to get back, there are 4 reaches in Angat River. So as you can see, there is inflow and the outflow. So this is the graph of the reach 1. The wool lines are the outflow of reach 1 and the broken lines are the inflow of the reach 1. So as we can see, they are almost equal. A little bit not, but they are almost equal. So next, the reach 2, inflow then outflow. So as we can see, the broken lines again are the inflow from the reach 2 and the wool lines are the outflow from reach 2. Again, they are almost equal, but not the same as almost equal of the reach 1. So next, the reach 3, the inflow and the outflow. So that's it. Again, they are almost equal. So reach 4, inflow, outflow. Then again, they are almost equal. Inflow and outflow are almost equal. So as for the conclusion, for the reaches, inflow and outflow are almost equal. So to the outlet, outlet is any hole or opening that allows water or gas to get out is an outlet. The place where water runs out of a lake and into a river is one example of an outlet. So there is just one outlet for the Angat River, which is draining to a stream in Pampanga River Basin. So as what I said, the Angat River is one of the sub-basin of Pampanga River Basin. So as we can see, the outflow, there's no inflow, of course. So yan. The outflow of the Angat River to the Pampanga River is 80, amounting more than 70 cubic meter per second. So imagine how big is the amount of water that can contribute of the Angat River to the Pampanga River for just a month. So thanks to Angat Dam. So next, so these are the physiographic factors. So we're going to start to slope. So slope, 30 degrees basin slope and 5 degrees basin slope. So the highest slope has the fastest travel time. So next, the size of the river. So long distance, long travel time, then short distance, fast travel time, of course. So next, the shape of the river. So shorter distance, less travel time, then long distance, long travel time, of course. So straight versus meandering flow path. So straight path has the fastest travel time, then the meandering flow path has the longest travel time because of the certain barriers when water flows to this river. So next, the elevation. So when it comes to elevation, it's just the same of the slope. The highest slope has the fastest travel time, and the lower slope has the lowest travel time. So almost done. Thank you to www.worldweatheronline.com, earthgoogle.com, www.zonews.com, www.fslorsedu, www.revelb.com, www.lmnoeng.com, www.engineercolostate.edu, www.tanfollen.com, pobsurgeusgs.gov, weatherspark.com, www.google.com, www.youtube.com, www.researchgate.net, www.xmswiki.com, and climatedata.org, ppp.gov.ph. So to all our references, thank you so much. And thank you for watching. God bless you. Thank you. Thank you and God bless you. Thanks for watching.